Hello. Hello, Ramesh.
Hello, sir.
Okay. Arjun. എന്ത് ജോയിൻ ആവാത്തെ? കുറെ പേര് ജോയിൻ ആവാനുണ്ടല്ലോ. ഒന്ന് പെട്ടെന്ന് ജോയിൻ ആവാൻ പറയാട്ടോ. നിങ്ങളുടെ ഗ്രൂപ്പിൽ പറയാം. ഓക്കെ, അപ്പോൾ കഴിഞ്ഞ ക്ലാസ്സിൽ നമ്മൾ എന്താ ഡിസ്കസ് ചെയ്തത്? സെക്കൻഡ് മോഡ്യൂൾ. അപ്പോൾ സെക്കൻഡ് മോഡ്യൂളിൽ ഏത് ടോപ്പിക്കാണ് ഡിസ്കസ് ചെയ്തത്? ഫസ്റ്റ് ടോപ്പിക്, അതായത് പ്രോബ്ലം റിഡക്ഷൻ ആൻഡ് AOS algorithm, its working. AOS star algorithm ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്, ഇതിന്റെ വർക്കിംഗ് ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. ഇപ്പോൾ സെക്കൻഡ് മോഡ്യൂൾ നമ്മളിവിടെ ഫിനിഷ് ചെയ്തിരിക്കുകയാണ്. നെക്സ്റ്റ് നമ്മൾ തേർഡ് മോഡ്യൂൾ സ്റ്റാർട്ട് ചെയ്യും. ഓക്കെ, സോ തേർഡ് മോഡ്യൂൾ നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത് എന്താണെന്ന് വെച്ചാൽ, which are the different representational schemes. Okay, that is, there are different ways to represent knowledge. Okay, you need to process the knowledge to get a solution. So before processing it, we need to represent the knowledge. Okay, to represent the knowledge in artificial intelligence, there are different ways that we want to study in this module. AI representational schemes, first part of this module. Okay, the first part of this module, we want to study and familiarize with various representational schemes in AI. Okay, so which are the this is AI representational schemes. Okay, this is the first part of the module. Okay, this is the first part of the module. Module third, we want to study various representational schemes. Okay, in the second part, we will study the machine learning. Okay, topics related to that. Previously, in this previous semester, we studied some basics of machine learning. That topics like that we will study. Okay, first part we will entirely focus on the knowledge representation, and there are different methods for representing the knowledge. Which are the different methods for representing knowledge? One is using the propositional predicate calculus. This is the first method. Propositional and predicate calculus can be used for representing the knowledge. Second method is semantic networks. Okay, second method is semantic networks, and the third method is frames. It's another concept, frames. Okay, the fourth method is conceptual dependency. This is conceptual dependency. And the fifth method is scripts. Okay, scripts. So there are 5 ways to represent knowledge in AI, and we need to study the basics of each concepts. Okay, start from the propositional and predicate calculus or from semantic nets. No issues. So these are all independent topics. Okay, so we can start from anywhere, no problem. But it is better to start from the propositional and predicate calculus. Okay, I think you already studied propositional and predicate calculus basic concepts. Okay, you already did the concepts. just giving an overview. Okay, I'll give an overview about this. And what is propositional predicate calculus? So I'm moving to this portion. This is semantic networks. Okay, just to go through it, and in the first, and I will show the contents. Semantic networks. This is semantics. Okay, so this is basically a graph. Okay, semantic network is a graph. Graph is used for representing the knowledge. Okay, so this is semantic network. Okay, I'm going to the semantic network topic just to familiarize with this. And so what is semantic network is simple. Suppose a sentence is given. For example, John gave the book to Mary. Then we want to represent that in predicate calculus. Okay, this is the corresponding predicate calculation. Then we want to represent it in semantic network. This is the big network representation of this sentence. Okay, so just to familiarize with the concept. Okay, so these are all semantic networks, and this is another semantic network. Okay, this is also semantic network. Okay, and we will discuss frames. Frames, another representation scheme, and this is the basic. This is a simple frame system. Okay. I'm trying to give an overview about what we are going to study in this module, in the first part of this module. And in the first part, we will try to concentrate on the various representation schemes. I just given an overview about the semantic network. Okay. Next, this is the frame system. Okay. We want to represent the knowledge in the frame system. Okay, this is frame system example. Just note it. Just to note it. This is frame system and create a mind map. Okay, this is frame system. Okay, this is another way of representing. Another is conceptual dependency. Okay, conceptual dependency. We will represent the knowledge in this way. For example, sentence is given, John throws the ball. We will represent it in this way. Okay, this is the corresponding conceptual dependency representation of this sentence. Okay. These are all various conceptual formats. Okay. These are all conceptual dependency. In the future classes, we will focus on this. Okay, just I'm giving an overview. Next, we will focus on scripting. Okay, so what is scripting means? This is the concept of script. This is another representation. This is a script representation. Just note it. This is a script. Okay, script format. Okay, then. Last, propositional logic and predicate logic. Okay. So we will start from the propositional logic and predicate logic. Okay. While we are discussing the history of AI, we studied. This is one of the oldest concepts developed. Okay. Still, we are using the propositional logic and predicate logic for the knowledge representation. So, first we will start our discussion from the proposition. Okay. So, again, there are various ways to represent knowledge. Just you got an overview about each now. Now we are focusing on the propositional and predicate calculus. This section. Okay. This section we are focusing. Okay. It's page number 13. Okay. Now, so what is proposition? What is propositional logic? Propositional logic, it contains propositional symbols. Okay. Each symbol denotes a proposition. Just note it. We can define propositional logic where it contains propositional symbols. Each symbol denotes a proposition. What is a proposition? A proposition is a statements about the world that may be true or false. Okay. What is a proposition? Proposition is a statement about the world that may be true or false. So, for example, the car is red. The car is red is a statement. Basically, it is about knowledge, and we will attach a symbol P to this statement. So, the symbol P represents knowledge. The car is red. Okay. Okay. So, this is propositional logic. Okay. This is the definition of propositional logic. And next, we are trying to understand what is propositional sentence. Okay. So, what is a sentence? A sentence contains various statements. Okay. So, these are just like rules. Negation of a sentence is a sentence. Negation of a sentence is a sentence. Conjunction sentences is another sentence. Disjunction of two sentences is another sentence. Implication of one sentence from another sentence is another sentence. P implies Q. Okay. Equivalence of two sentences is a sentence. These are all the rules of sentence in propositional logic. Basically, we present a sentence using a symbol. Then we can combine the sentences using the rules. Okay. We can use negation operation, intersection, union, implication, and bidirectional equivalence. Okay. Equivalence relation. What is the equivalence relation? Double arrow mark. This is an equivalence relation. We can apply operation and create complicated sentences in propositional sentence system. Okay. Next, we will discuss about well-formed formula. So, what is well-formed formula? Legal sentences is called well-formed formula. Okay. Legal sentences are called well-formed formulas. Okay. Next, we will discuss about propositional calculus semantics. Okay. These are all comes under propositional logic, and these are all small concepts under the propositional logic. Okay. So, well-formed formula means legal sentences are called WFF. Propositional calculus semantics. What is its meaning? Truth value of a sentence is determined by these operations. These are the different operations. These different operations result in different truth values. Okay. For each, after applying this operation, we can evaluate the propositional sentence to get a truth value. For example, implication is, you already know what is negation. Negation you already know. Similarly, union, intersection also you know. For example, suppose P is a sentence, P is a propositional statement, Q is a propositional statement, P is 1, Q is 1, then what is 1 intersection 1? Section 1 is 1. You know the truth table, so we don't about that too much. Similarly, P union Q, truth table you know. Okay. Similarly, negation you know. Okay. Now the important thing is implication. So implication means what? This is the table of implication. So suppose P and Q is given. P is this, Q is given. P implies Q means what is P implies Q? So it will come only on this case. Okay, only on this case. Okay. One case. P is 1 and Q is 0. Then the result P implies F. All other cases true. Okay. So basically P sentences. Okay. Just try to understand that concept. Here is a symbolic symbol which represents some knowledge. Similarly, Q is a symbol that represents some other knowledge. If we apply the implication P implies Q, it creates another knowledge, and using this semantic, we can evaluate it. Okay, we can evaluate it. That is the concept of semantics. Okay, we can apply this semantic knowledge to a sentence. Okay. Next, similarly, equivalence is there. True and true is true. False and false is true. And other case is 0. So you should remember these concepts. These truth tables always. Okay. Okay. Fajr, is it okay now? Fajr. Ashwadi. Anyone is there? Saurabh. Okay, okay. Okay. Next. So, next we will move to another concept. It is called tautology and contradiction. Okay. So, what is tautology? What is contradiction? What is tautology and what is contradiction? I didn't return it because I studied what is tautology, what is contradiction. If all the statements, all the cases are evaluated to 1, it is called tautology. Okay, tautology. You already, okay, so this is artificial intelligence. So the basic lies in the proposed order concept. Okay. Tautology, I think you studied in the DCS, Discrete Computational Structures. Okay. Contradiction concept. If it is evaluated, then all the cases result in 0. I think it is contradiction. Okay. So just check it. Okay. Just check it. Similarly, other laws will be there. Various laws various laws like De Morgan's law can be applied here. Okay, various law. That also you just take it. Okay, various laws means De Morgan's law. Then other laws of also there. Okay, just anyway. First, I given in the what I had done is that in this topic I given an overview about the propositional logic and what is proposition means. For example, I want to represent a knowledge in the form of a symbol. The car is red. Okay. Present this statement using a single symbol. Okay. We can represent various knowledge using a single symbol. And we can apply various operations like negation, intersection, union, implication, and bidirectional equivalence to create knowledges. Okay. Next, we studied about the well-formed formula. What is a sentence in the propositional form which is linear is called a well-formed formula. And next we study about the semantics. Semantics means how we evaluate a propositional statement. Okay, we can apply these rules, that is, this truth table, to evaluate the propositional sentences. Okay, so next concept comes under proposition is tautology and contradiction. Okay, this is the case you just refer. Various laws are there in the propositional logic. Okay, for example, the best is De Morgan's law. De Morgan's law can be applied in De Morgan's law. A union B whole complement is A complement intersection B complement and other alternative. A intersection complement is equal to A union, A complement union B complement. So De Morgan's law is so various laws like this law of contradiction like that also exist. Just to refer that. Okay. Anyway, and this is about the propositional logic representation of knowledge. And next, we want to discuss about the predicate logic. Now, so next we will discuss about predicate logic. Okay. The propositional calculus in the proposal. So I'm going to discuss about the predicate calculus. Okay, this is also one of the oldest representational scheme. Okay, predicators and propositional calculus. So what is predicate calculus? Propositional calculus, each atomic symbol denotes a single proposition. Okay, so what is the disadvantage of a propositional calculus? The propositional calculus, each atomic symbol denotes a single proposition. Okay, there is no way to access the components of the individual proposition. Okay, for example, it is rained on Tuesday. These are the two individual components of this proposition. Okay, so we can't manipulate this knowledge. There is no way to manipulate this or these individual components in the propositional calculus. So we need another system of knowledge representation that is called predicate calculus. The predicate calculus provides this facility. That is, it can process the individual components within a sentence. Okay, that is the advantage of predicate calculus. Here, create a predicate that describe the relationship between individual components. Okay, here we can create a predicate. Predicate means, what is predicate? A predicate is that describe a relationship between individual components. For example, Tuesday, just it. So the individual components in a sentence is put inside the bracket, and these are considered as symbols. And a predicate is attached to these symbols. That is why it's called predicate calculus. Here, whether is the predicate, symbols are Tuesday, rain. Okay, so we can process more basic components. Okay, we can process the basic components within a sentence using this predicate calculus. So this is the concept. Next, so basically, what is the predicate calculus syntax? Predicate calculus symbols represent variables, constant, function, or other predicates. Okay. As I told, there are two parts. One is called the predicate part. Okay. This is the predicate part, and this is the symbol part. Okay. In the predicate, in the symbol part, what symbols represent variable, constant, functions, or other predicates. What is symbols can be these are the symbols can be variables, constants, some functions, or other predicates. Okay, these are, it may be, okay, the symbols may be this. Okay. Just try to understand that concept. For example, f of xy is the predicate, x and y are the variables, and father David means father of David. Okay, I mean David is a father. It's like etc. We can represent knowledge in this way. Okay. Next, predicate calculus sentences. Okay. Now the question is, this is a single sentence. Okay. How can form more complicated sentences in predicate calculus? How can more complicated sentences in predicate calculus? Predicate calculus, for example, this is a sentence. Okay, this is a single sentence representation. Okay, suppose I want to represent a story. Okay, a story contains a lot of sentences. First of all, I want to represent each sentence in the predicate format. Then I want to apply these operators: negation, intersection, union, implication, violation, for all exist. Okay, for all and exist. For all, there exist symbols form new sentences. Okay, to form new sentences. More complicated sentences can be formed by using these operators, of which the most important is use of for all and there exist symbols. We are going to the first order predicate logic. Okay, this is also one of this oldest developed concept. Okay. First order predicate logic. Predicate calculus that use identified variables called first order predicate. So what is first order predicate logic? In the previous year we studied about what is predicate logic. Okay, what is predicate calculus? The use of predicate calculus, how can represent various sentences in predicates, then how can form more complicated predicate calculus sentences by applying these operators. Next, here to discuss about what is first order predicate logic. Okay, what is the concept of predicate logic? So predicate calculus that uses quantified variables, okay, is called the first order predicate calculus. Then that is the variables countable. That is, it is quantifiable. Okay, quantified variables. That is, we will use the symbols or variables which are quantified. That's the property. Okay, this property should be satisfied. Okay, then it is called the first order predicate. Predicate calculus that uses quantified variables called the first order predicate calculus. The universal quantifier for all indicate the sentence is for all values of the variable. Okay, so just note this. Okay, suppose I want to represent a knowledge. Just note this. Here, this is one representation. Okay. For example, all men, like all students, likes ice cream. Okay. I'm giving a sentence. All ice cream. Okay. This is an English sentence. Okay. This is an English sentence. I want to represent it in predicate calculus. Then what I will do is that, which are the symbols within this? One is students. Okay, students is a symbol. We can consider it as a symbol, and ice cream is another symbol. Okay, or variable. Okay, I'm not saying students is a variable, ice cream another variable. So what I have done is that for students I given a letter X. Okay, students I given a letter X. Okay, students I given a letter X, and for ice cream I given a. I didn't given any letter. If needed, I can give, no problem. Okay, ice cream. Okay. Now, which is the predicate in this? Likes. Likes is the predicate. Okay. Predicate. So, likes is the predicate. Then, I formed a sentence in this way. Okay. Now, just note this. Okay. Now just note it. So now capital X is students. Screen I didn't give any. If I needed, I can give, no problem. So basically, what I identified the symbols within this. Okay, one is students and another is ice cream. Then I put it in this. Okay, put it in this bracket. Okay, X comma ice cream, and then I identified which predicate. Likes is the predicate. Okay, likes is the predicate. So likes of X comma ice cream. Okay, likes of X comma ice cream. Then I want to represent this also. All students. How can it is possible? Just note this. Students like ice cream is okay, but here is all. Okay, all is there. I want to represent another knowledge all here. All here. Okay. Just note this. All. How can represent this also? All is. Then what is that? All students likes ice cream. I attached another symbol for all. For all X. Okay, for all X. This term I attach with this. Okay, then what is the final meaning of this predicate calculus? All students likes ice cream. So this meaning is students like ice cream, but I want to represent the knowledge all students like ice cream. So what I have is that to X. X is the students, all students. Okay, X is the student. For that, a quantifier. Okay, quantifier. So that is all. All students like ice cream. So This is the concept. So if these variables are quantifiable, then predicate calculus is called the first order predicate calculus. So just note this concept, just understand this concept. And next is another concept is existential quantifier. Okay, indicates the sentence is true for at least one of the term. Anyway, we can discuss that in the next class. So, okay, please give your attendance in the chat box.